Alright, hello everybody. This video is going over the 1.6 multiple choice and FRQs in the Unit 1 booklet. Number 1 says the complete photoelectron spectrum of an element is given to the right. Which of the following electron configurations is consistent with the spectrum? So remember, when you're looking at a PES spectrum, on the left side of the graph is going to be the number of electrons, and on the bottom is going to be the binding energy. Remember, as the nuclear charge of an atom increases, it's going to have a larger binding energy because of that pull on the electrons. Here we have, reading from left to right, the first peak, it is 2 electrons, and that is the first sublevel, so that's going to be 1s2. Then we have our next peak, 2s2, and then we have 2p6, and then we have 3s2, and this 3p orbital is only 3 electrons, so we're going to be ending in 3p3. So our answer would be B, which is phosphorus. All right, number 2 says the complete photoelectron spectrum for an element is shown below. Which of the following observations would provide evidence that the spectrum is consistent with the atomic model of the element? So first thing I want to do is identify which element is this. So we have our first peak, which is going to be 1s2, and our second peak, which is going to be 2s, and it's half the size, or only 1 electron. So 1s2, 2s1 would be lithium. Now remember, lithium is a group 1 element, which means it has 1 valence electron. So if it were to form an ionic compound, it would have a charge of positive 1. So now let's look at our answer choices. A says a neutral atom of the element contains exactly 2 electrons. That is not true. It has a total of 3 electrons. B says the element does not react with other elements to form compounds. That is not true. Lithium is a metal, and it is a common metal used in ionic compounds. C says in its compounds, the element tends to form ions with a charge of positive 1. That would be correct because of what we stated at the beginning of this question. The photoelectron spectrum for the element nitrogen is represented below. Which of the following best explains how the spectrum is consistent with the electron shell model of the atom? So let's go through some of these answer choices. A says the leftmost peak represents the valence electrons. That would be false, because remember, as we're reading from left to right, it goes from the core electrons all the way to the valence electrons. So this first peak would be 1s2, this second peak would be 2s2, and this third peak would be 2p3. So A could not be correct because the valence electrons are these 2 peaks over here. Then B says the 2 peaks at the right represent a total of 3 electrons. That is also not correct, because since we have 2s2 and 2p3, that equals a total of 5 electrons. So B is not correct. Then we go into C and D, which talk about binding energy. So remember, binding energy is the amount of energy required to separate a particle from a system of particles. You can see by reading this definition that it's very similar to ionization energy. Well, binding energy is kind of an umbrella term, so ionization energy is a type of binding energy. So as you can see here on the bottom of the PES spectrum, the values on the bottom are binding energy. So we can see that 1s2 has the largest binding energy and 2p3 has the smallest binding energy. We know that because those 1s2 electrons are closer to the nucleus, so they have a stronger attractive force, and they're being pulled a lot stronger than those 2p3 electrons. So now if we look at our C and D options, C says the electron in 1s sublevel have the smallest binding energy. That is not correct. D says the electrons in the 2p sublevel have the smallest binding energy, and that is correct. 4 says a sample containing atoms of carbon and fluorine were analyzed using X-ray photoelectron spectroscopy. The portion of the spectrum showing the 1s peaks for the atoms of the two elements is shown. Which of the following correctly identifies the 1s peak for the F atoms and provides an appropriate explanation? So just like we discussed in the previous example, the higher the nuclear charge, which is the number of protons, within the same period, the more binding energy an atom will have. So if we're looking at carbon and fluorine on the periodic table, fluorine has a higher nuclear charge than carbon. So because of that, the binding energy for fluorine's electrons are going to be stronger or larger than the binding energy for carbon's electrons. So our answer would be B, peak X, because fluorine has a greater nuclear charge than carbon, which means it has a stronger pull on its electrons. 5. The photoelectron spectra of the 1s electrons of two isoelectronic species, Ca, 2 positive, and Ar, are shown opposite. Which of the following correctly identifies the species associated with peak X and provides a valid justification? So we're going to be looking at something very similar to the last one. So we have our two atoms, or in this case an ion and an atom, Ca2 positive and Ar. So first thing I want to look at is the number of protons and the number of electrons. So calcium has 20 protons, and since it has a 2 positive charge, we know that it lost 2 electrons, so it has 18 electrons. And argon has 18 protons, and it's not an ion, so it's also going to have 18 electrons. So you can see these two substances have the same number of electrons, but since the calcium ion has 2 extra protons, it's going to have a stronger pull on those electrons, which means the binding energy is going to be greater. Since X has a larger binding energy, we know that X is going to be Ca positive 2. So we can go ahead and cancel out A and B for potential options. Then we can look at our option choices. C says the calcium ion, because its nuclear mass is greater than that of Ar. Now you could consider that to be a stretch, but it is kind of correct, but let's move on to D just in case that is a better option choice. D says calcium ion because its nucleus has 2 more protons than the nucleus of Ar. Since that is more specific to why the binding energy is stronger, D would be your answer choice. 6 says the photoelectron spectra opposite show the energy required to remove a 1s electron from nitrogen atom and from an oxygen atom. Which of the following statements best accounts for the peak in the upper spectrum being to the right of the peak in the lower spectrum? So again, let's look at our amount of protons in these two options. So in nitrogen, we have 7 protons, and in oxygen, we have 8 protons. So just like stated a few times at this point, we know these are in the same energy level, and since oxygen has more protons pulling out its electrons, it's going to have a stronger binding energy. So let's go ahead and look at our answer choices. A says nitrogen atoms have a filled p sublevel. That is not true. Nitrogen is ending in 2p3, so that would not be a correct option. B says there are more electron-electron repulsions in oxygen atoms than in nitrogen atoms. So B is technically true because oxygen has 1 extra electron in that outer shell. However, the repulsions between the electrons does not technically increase or decrease the binding energy. So we're going to move forward on that. C says electrons in the p subshell of oxygen atoms provide more shielding than electrons in the p subshell of nitrogen atoms. In these PES spectrums, we're talking about 1s electrons, so the p subshells are actually past the 1s, so that would not apply to this specific question. And D says nitrogen atoms have a smaller nuclear charge than oxygen atoms, and we know the nuclear charge, or the number of protons, has a large factor on the binding energy of the atom, so we know D would be the answer. All right, the 1.6 FRQ questions. One says the complete photoelectron spectrum of an element in its ground state is represented below. Based on the spectrum, write the ground state electron configuration of the element and identify the element. So remember, reading from left to right, we're starting at the very first sublevel, which is going to be 1s2. Then we have 2s2, 2p6, because we know that one of these blocks is going to equal 2 electrons. Then we have 3s2, 3p6, and then we have 4s2. So if we look at 4s2, that would be calcium. And then we can just write out our electron configuration. So we have 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. All right, B says, calculate the wavelength in meters of electromagnetic radiation needed to remove an electron from the valence shell of an atom of the element. So the equation to solve this is going to be the wavelength from energy equation, which means we're going to have energy equals Planck's constant times the speed of light over the wavelength. So if we were solving for wavelength, our new equation would be Planck's constant times speed of light divided by the energy. So we know Planck's constant is 6.626 times 10 to the negative 34th. And we know that our speed of light is 2.998 times 10 to the 8th meters per second with a negative first power. And then from our PES spectrum, remember in this question it's asking for the electrons in the valence shell, which would be this 4s2 peak. So we know we're going to be using this as our energy. So we're going to be dividing it by 0.980 times 10 to the negative 18th. So then we can go ahead and solve, and when we do that, we get our wavelength as 2.03 times 10 to the negative 7th meters. And I do want to mention that you can derive this from what's given on your AP Chemistry reference sheet. So on your reference sheet, you're given energy equals Planck's constant times frequency and speed of light equals wavelength times frequency. You can see how both of these have frequency. So if you set them both to equal V, then you can make the energy over Planck's constant equal the speed of light over wavelength. And then to get E by itself, you would just multiply H on both sides. So that would give you your final equation of energy equals speed of light times Planck's constant over wavelength. All right, number 2 says the photoelectron spectrum for an unknown element is shown below. Based on the photoelectron spectrum, identify the unknown element and write its electron configuration. Remember, reading from left to the right, you are starting at the first sublevel, which is always 1s. Each one of these blocks in this case is going to be 1 electron. So we know this is 1s2, this is 2s2, this is 2p6, this is 3s2, and we only have 3 electrons in the 3p sublevel. So writing out our electron configuration, it would be 1s2, 2s2, 2p6, 3s2, 3p3, which would end up being phosphorus. And B says, consider the element in the periodic table that is directly to the right of the element identified in part A. Would the peak of this element appear to the left of, the right of, or in the same position as the peak of the element in part A? So we know the peak or the element in part A is going to be phosphorus. And so basically it's asking for the element to the right, which would be sulfur. So let's look at phosphorus and let's look at sulfur. So we know phosphorus has an atomic number of 15, which means it has 15 protons, and sulfur has 16 protons. So we know, since it's in the same energy level, the larger the nuclear charge, the bigger the binding energy of that atom. So we know that sulfur is going to have a larger binding energy. So we're going to answer the question, and it says, would the peak of this element appear to the left, right, or in the same position as the element in part A? And we know that sulfur will appear to the left because it has a stronger nuclear charge, which means it has a larger binding energy. Okay, I hope that helps everybody. If you have any questions on 1.6, please let me know. I am happy to help. I hope you have a great day.